Hi everyone. Welcome to Cyclical Matter in Conversation, hosted on les rencontres interdisciplinaires d'Hexagram 2020, edition Saint-Poétique. The title of this very first edition of an Hexagram Interdisciplinary Summit refers to the neologism created by Canadian Bette Dempster in 1998, which she invented as an alternative to urban planning analysis centered on the concept of autopoiesis. The symposium is conceived under this key concept of distribution and sharing, as elaborated further by Donna Haraway in 2016. The autonomous subject is a fiction. Autonomy, like agency elsewhere, only exists by, with, and in the sharing between multiple forces, materialities, processes, and entities, human and other than human. Symbiotic processes are expressed in collaborations, relations, and coextensions. The central research question is expressed as follows. How can the current context, including the pandemic happening in the era of said Anthropocene, allow for the experimentation of the sharing of autonomy and agency? In the context of the pandemic, a large part of activities are expressed digitally. We propose to create once more in these troubled and troubling interstices, along with other actants of the planet. The organization of this symposium is a pooling of interest between organizers, publics, and participants. The digital platform proposes to go beyond dissemination by adopting a participatory method. As many others have expressed, it is difficult for us to endorse the idea that social distancing is the key to curbing the spread of COVID-19 pandemic. It is therefore necessary and urgent to invent new ways of practicing social solidarity. The digital platform, produced jointly by Hexagram Scientific Committee, the production team, participants, and publics, is a full-fledged research creation project. Our stance is eminently practico-reflexive, to reflect collectively on the sharing of autonomy in action, to practice the sharing of autonomy and of agency, social solidarity, and research in action. Today, we have the pleasure to discuss with the collective Cyclical Matter and environmental chemist Yves Gélinas. Inspired by design principles of biomimicry and cradle to cradle, this public discussion and cooking show will address the research creation process of the Cyclical Matter Collective, their work with biocomposites, and the challenges, be they conceptual, methodological, technical, or health-related, of working with such materialities. For this special occasion, design and computation art students from Concordia University enrolled in the seminar Critical Materiality are also with us. Critical Materiality is an advanced special topic research studio course that opens up new perspective, joint methods, and lines of inquiries between design and computation arts disciplines with both graduate and undergraduate students. With a special emphasis on making and process, students leverage material technological exploration, such as objects, narratives, visual, environments, performances. And they develop new artistic and public responses to social environmental topics. The course asks questions such as how to encourage intelligent and sustainable engagement with matter. How would response to public problems be different were we to consider the vibrancy, the agency, and the responsiveness of materiality? And how to develop innovative expressions of the coupled matter form to design sensitive and responsive objects? Finally, how do materials influence the experiments and the experiences that we enable as designer practitioners? Before we start, let me introduce the presenters. Vanessa Mardi-Rossian. Vanessa Mardi-Rossian is a textile designer. She's been working in the field for over 20 years. Vanessa Mardi-Rossian is concerned about the environmental impact of fashion industry. For 5 years, she's been interested in new ways to design dyes and materials. As part of her PhD, she's developing natural and non-toxic dyes from bacteria that feed on food waste. This research combining art and science method allows her to develop an eco-literacy of design that fosters a better understanding of the impact of our production on ecosystems. Alex Blackmeyer is an interdisciplinary artist and researcher based in Montreal. She explores hybrid ecologies through digital, textile, and biomaterial practice. Whether developing haptic performance clothing or textile dyes with pigment-producing bacteria, her work is largely centered around the themes of empathy, play, connectivity, the ephemeral, and materiality. She was a research assistant at XS Lab and Matra Lab, as well as a costume designer, contributing to the fields of electronic textiles. Miri Chikanovic, by merging video, performance, and sculpture, Miri Chikanovic creates installations that bridge the gap between notions of decomposition and rebirth. Born in Armenia and having lived in Jerusalem, she now works in Montreal. The diversity of her cultural origins and the many languages she speaks serve artists by creating imaginative spaces. In these places, the artist invites viewers to become active participants in what she hopes will be a transformative experience. And finally, Yves Gélina. Dr. Yves Gélina obtained his PhD in environmental science in 1997 from Université du Québec à Montréal, followed by postdoctoral studies at the University of Massachusetts at Amherst and the University of Washington in Seattle. He's now a professor of chemistry and biochemistry at Concordia University. And Dr. Gélina's work focuses on the cycling of organic carbon in the environment in relation with the health of aquatic ecosystems, the exchanges of greenhouse gases between surface water and the atmosphere, and climate change. He also specialized in the assessment of the sources, pathways, and sinks of organic contaminants in the environment. And he uses classical wet chemistry approaches coupled to an array of technologically advanced mass spectrometers to analyze organic compounds, as well as the interaction at the interface between the organic and inorganic domains, and between the liquid and solid phases. So before we start, I really encourage the public to ask questions in the chat, as these questions will be answered spontaneously during the discussion and after during the question period. So collective Cyclical Matter, I will let you introduce yourself.
Sounds good. I'm Alex Blackmeyer. Obviously, Alice just introduced me, but just to give a little bit more context for today, I've been exploring bioplastics for a couple of years, though it's been much more intensive this past year, and particularly since the beginning of the pandemic. In my work and play, I'm often engaging with materiality and ecologies of softness, and these themes kind of all came together perfectly with this project. And while I'm interested in sustainability and researching alternatives to plastics, though bioplastics and sourcing their base materials can of course be complicated and bring up ethical issues, but we can talk about that later. What really drove me to start creating and manipulating bioplastics and composites was more the sensorial aspect, their textile and skin-like properties, and the possibility of being able to incorporate them into costume design.
Thanks. Thanks, Alice, for this nice introduction. So to tell a bit more about myself, of course, my background is in fashion and textile for the last 20 years, but particularly today, why I'm so interested into bioplastics and biocomposites. This interest started like about 3 years ago when I discovered the open source website materium.org. So maybe Alice, if you can share the link on the chat. This community of artists started this open source website to share the learnings. Like already Victor Papanek in the 70s started about this, the importance of sharing good findings and spreading the ideas. And as a community, by working together, collaborating, we can push further this idea of materiality. Miri?
So I'm Miri. I'm a master's student at Concordia, and I really, same as Alex said, the sensual or kind of sensorial aspect of bioplastic really attracts me and makes me move into trying to figure out what other things we can make with it. And yeah, I'm really excited to share our findings and explorations today. And I know most of the people who are with us today, the cameras are off, but I wonder if you by any chance have your bioplastic specimens that you've tried at home to share with us and just put them in the camera or share it in some way. We're really curious how this mode of transmission of yay, I see some.
Wait. Well, that's great.
Well, I wanted to just ask you a question, because if you look closely, there's mold growing, and that's been happening to all of them.
Okay, I'm going to address that. Yeah.
I tried the toothbrush technique. Maybe I did it wrong, but it's been over a week and it keeps, coming back. And so I took the plates off, but now they started deforming. I have other samples and, the shapes are changing, but the mold keeps growing. Yeah.
Okay, so we're going to address that. Thank you, Larissa, for sharing. So what we're going to do next, before to start cooking live, we're going to take you to our former experiments. Like on this tray today, you see a mix of different techniques. Like until now, we mostly experimented with gelatin, like you could see on the platform, whether on the video tutorial, or in the articles. It was mostly with gelatin and animal bio product, mostly made from skin and bones. But today we really wanted to address animal-free materiality. So it's why we're gonna work with Agar. And we are very happy to have Eve with us today. And that maybe Eve, could you quickly explain the materiality or the ingredients of agar, and glycerin, our most ingredients?
Sure, absolutely. Just before starting, just to say that thanks to Vanessa and everyone else, I'm discovering a brand new world, right? In chemistry, it's very different. So it's really nice to see not only what you're doing in that field, but also that you're trying to connect with science and trying to build bridges between the two communities. And I do think that it has to come from your side, because unfortunately on the science side of things, there's more resistance into building these bridges. So I think what you're doing is really, really interesting. Okay, so the difference between gelatin and agar, well, the difference is major. First of all, gelatin is a protein. So as Vanessa was saying, it's a protein that's extracted from collagen. Collagen is the most important proteins in humans, in animals in general. And it's extracted by running a whole series of extraction procedures, purification procedures, and cleanup and everything. And so in the end, what you get is broken down proteins, small peptides that we call. But the main difference between agar and gelatin is that aside from gelatin coming from animals and agar coming from plants, is the fact that the quality of the gelatin differs, because not every company will go through the different steps into the cleanup of the gelatin. And so you get different qualities. And so when you try to do something, and I think Vanessa has faced this issue as well in the past, you don't get the same end product simply because the composition of the gelatin is different from batch to batch, company, source to source. Agar is a sugar, as I said. So it's actually a sugar that's extracted from algae, red algae, and it's a molecule. It's a long polymer of sugar, and its role in cells is a structural role. So it helps keeping the shape of cell walls from these algae. And so because it has a structural role, we can understand that it's normal that when you extract it and you build something with it using something that we call a plastifier, that you will get something solid, something that solidifies and that you can use to make the nice objects that you're making. And so difference, sugar for agar, it's vegetal, it's not animals from an animal source. And also the end product of agar, there's also quite a few steps into purifying it, but the steps are used mostly when you want to produce an agar that is used in food products. And so to obtain that quality, you need different steps. But for what is being done here with Agar and building these plates and everything. Not all of these steps are necessary, and the end product is more uniform between the different sources than for gelatin.
Thank you very much, Lee, for this very useful information. I'm gonna take you through a few of the experiment we did. Like, so on the top, you see just Agar Experiments. So what you have to know, the main difference between Agar and gelatin is the way they shrinks. Like if you see, like this is the mold we used, for example, and this is an Agar plate, and this is the same mold for gelatin. So when you see here, like on the gelatin, you have about 10, sometimes 15% of shrinkage, while on the Agar side, you have like 30 to 35% of shrinkage. So this quality can be interesting according to what you want to do, but this is something you really have to keep into consideration. So on this big plate, I didn't get any mold at all, only this one. Oops, okay, so if I can go a bit closer, you see like some mold. So what I do usually, I get some white vinegar and a toothbrush, like I was explaining, and I'm sure, Larissa, you did it too, but just I'm gonna show you how I do that. So I brush it, and then with my finger, I really rub it. And what is very important, like, you know, like you don't have it anymore, it really disappears, but you have to check it out. Like when you have high fever and then you check out on the on your health like regularly, is the same for, this is not alive, but this is like a natural material, so it reacts in different way according to humidity, temperature. So you have to check on it every day, and it needs really air temperature, room air to dry. So Larissa, you need to check every day on it and put vinegar until it's completely dry, and it should go. So what I want to explain also about agar, the difference mostly between agar and gelatin is agar stay supple and gelatin is much harder. So of course what you can play with that is with the dosage of glycerin, and maybe if you can explain a bit of the action of glycerin when we mix to the bioplastic or to the agar.
Sure, yes. So as I said, it's a plastifier. So glycerol or glycerin, it's the same thing, two different words for the same compound. It's a small organic molecule. And as I said before, for agar, for instance, they're long linear strands of sugars. So it's a polymer of sugars. And glycerin, when you put glycerin into a mix, it comes and inserts itself between these different strands. So you can think of Lego blocks, for instance. If you put Lego blocks together and many on top of one another, you're going to build a hard structure. Now, if you put, I don't know, a soft patch in between the blocks, you'll see that, you know, the structure is going to be more wobbly and not as rigid. And so that's exactly what glycerol is doing. Glycerol just inserts itself between the different strands and makes the structure more flexible. So more glycerol means more flexible, less glycerol means harder, more rigid.
Thank you. And I'm going to illustrate that straight away. Like here, for example, I put a full tablespoon of glycerin for only 2 grams of agar and 120 milliliters of water. And I get really something that this is 10 days old and it won't move. It's really stay flexible because there is a lot of glycerin. And here, on the other hand, I put only half a teaspoon of glycerin, and you know, I get like something like almost similar to gelatin. So you can play with this amount. Also, I played in purpose, I play here with food coloring in blue because I wanted just to concentrate on the plasticity of the materiality to see the differences. But most of the time we use really natural dyes. Like here, for example, I use artichokes. Here I used avocado, onion. Here is eggshells or coffee. And maybe Miri or Alex, you want to share your own experiment?
Sure. I mean, to carry on from where Eve was talking, just to give you a really good example of the difference between using quite a bit of glycerol and using very little. Actually, you can't really see my screen, but I'll hold up here. This was it was the same recipe, except for this one had 10 grams of glycerol and this one had 2.5. So you can see how when you add more glycerol, not only is it softer, but you also get less shrinkage. So that's something you can play with as well. It's a lot more flexible, maybe not exactly the kind of material you'd want if you're hoping to use it as a drinking glass or something, but it's really beautiful for other uses. And you get more of a cup-like material when you use less, although you can't use none because then it starts to crack and it doesn't hold itself together at all.
Yeah, if I can just say that we didn't mention why we were working with this challenge to create kind of usable tableware. I think, well, it started with Alice initiating us, pushing us to try and make tableware for the Sympoietic live event. And it transitions, and we really wanted as a team to focus on one kind of product, let's say, that we can really research and see what can we come up with. And that's why you see plates and cups and these kind of vessel-shaped materials. I would love also to share a bit about our methodology to show you a little bit how we worked as a team through this time. We used the platform called Airtable, where you see on the left, you see our name. So we had inputted what kind of experiment we're going to explore. We have the images of the results. They really help us because we can't really see each other and exchange. So this becomes a really rich document. See the recipes, and not only recipes, also notes. So for example, what happened to Larissa, maybe in a different home or a different time of the year, the mold won't occur because of the environmental changes. So we have these notes to also note these like small things that are maybe not following the recipe, but happen. And also part of our research team, we're called Cyclical Matters. The idea was to not only explore like biodegradable materiality, but in fact to reuse over and over and over again what we are making as creators. And that's also very interesting that we started adding that to our recipe. So for example, we do a regular recipe plus 35 grams of a second generation bioplastic. So we started to have these kind of very interesting, elaborate methodology that really is expanding.
And then, yeah, if I can also participate to this conversation, is what we really realized by doing this Airtable and this process of walking the three of us from our different kitchen without never seeing each other since March when we started, is that the importance of the balance between rigor and intuition. Intuition in a way that we are trying, like trials and errors, like about dosage, about ingredients, and rigors in the fact that we really keep track of everything we do, which ingredients, how much, because sometimes when we get something successful, we want to be sure it works again. And also this is something I would like to address to Eve in terms of methodology between art and science. What do you think about this balance? Because we tend to think about scientists as really regulars, but what about the intuition in science that we have mostly in art, where we try to bring more rigor?
Well, I mean, I think both fields, arts and science, have to gain from cross-fertilization between the two fields for sure. Intuition, imagination is really important in both fields. I mean, the main difference, one of the differences, I mean, I've read that not too long ago, but I think the formula is very well built. Arts expresses while science tests. And I mean, the approach that you're taking borrows a little bit from the scientific approach, but not completely. You see, in science, when we want to work on something, we start with facts. Okay, so what, for instance, we would have done is go to the literature and try to find as much information as possible on bioplastics and what people have tried, and see what's out there first, and then build the working hypotheses. And it could be anything. Working hypotheses could be how much glycerol will help with the rigidity of the material I'm building. So then I would use a scientific experimental design to build a series of experiments that would allow me to test this hypothesis. So the framework that we use in science is much more rigorous than it is in arts, from what I understand from the interactions that we've had in the past, 5 years now. But in the end, the most important thing, and you were right to say this, is not only intuition, but also imagination. And we have a lot to gain in the scientific world from borrowing the approaches that you're using by trying things. Mm-hmm. It's called serendipity in science. It doesn't happen often enough, but I think if we were more bolder in trying things and following our intuition, we could gain from that quite a bit, as long as, because it's essential, we don't have a choice in science but to follow a scientific approach that would allow us to publish our result and then get something out of the work we're doing. But there's a lot to be gained from both sides, and we could have a very long conversation on this, as we've had in the past with Nessa, right?
Right, and I was very happy and lucky to be part of your laboratory, and I could see, this kind of, I call it MacGyver approach, we need to do that, but, very intuitive. I mean, I could see you in a very intuitive way, even though you start from fact. So this is very enriching for me to see this aspect of science. Okay, so
we start cooking.
We can start cooking. I just want to say a last thing before, because you were mentioning something, Miri, about putting water, using drinks, and sometimes this one, for example, is made from avocado, but I tried to put it more waterproof. So I mixed in the recipe some a bit of beeswax. Yeah, beeswax, and I put the water, I left it 24 hours, and nothing is happening. It gives some waterproof aspect. And of course, you can see also the aspect is a bit of waxy, but when you want to make some object, you can get some interesting plastic aspect. And that being said, I think, it's time to cook. Live cooking show.
Live cooking show.
So this is a little pan. So today we're gonna use 3 different kind of agars because we wanted to show you different results. So for example, the one I'm using is this brand, like Lander Trading and Co. And we would like to mention also that next week we're gonna post on the platform the recipe we are making today, and also a little explanation about natural dyes and how we achieve them. So for today, do you want to talk about your own agar, Miriam?
Yeah, for sure. I actually am going to be really honest with you, and this is part of our work. This is the agar I was using since 2 years. I buy it in probably an Asian food store. It's used a lot in desserts. And I love this brand because I know it so well just by working with it for so long. But 2 days ago, we did a try with the same thing that I'm always using. You see, it's a really new pack, but the result was completely different. It turned to jam, and it's really interesting what Yves said, that it's basically a sugar, and it really feels like a texture of some kind of jam. So I was planning to use this today, but because it doesn't work per se, I will use a similar brand to Vanessa. But what is interesting is that it mentions the strength. So mine is 700 milligrams per 2 centimeters square. And Vanessa's is 900. So there's different consistencies of probably the active material.
Exactly. Yeah.
And I'm going to be working with a lab grade agar. So it's Fisher brand, and it's usually it's what we work in the biolab with at Concordia. It's something I'm working with it because it's something that I'm familiar with, and I'm familiar with it more in making agar plates to grow bacteria, etc., but have started using it for our bioplastic practice as well. And despite being like using it and liking it because I kind of understand it since we've been working together for so long. There are some frustrating aspects with it because rather than being in a powder like the ones that Miri and Vanessa are going to use, it's in a granule. It's a lot flakier, and so it takes a lot longer to dissolve. So I usually cook it for longer at a lower temperature.
Yeah, and just, before to start cooking, I wanted to show you the 3 examples here, and I don't know if you see very well, but this is the Asian one Miri was talking about. She was really unfortunate yesterday because we never had that problem before. And this quality is a bit less transparent and it shrinks a lot. Then this is the one we're gonna use today with Miri. We call it the Amazon because we order it on Amazon, but it's the Lander Trading Co. Strength 900, so it's more, more stable, and more shiny also, and tends to mold less. And this is the one Alex is talking about, and I don't know if you can see, but the little bits she's talking about, they are very difficult to dissolve, so we have to cook them much longer, and by cooking them much longer, water evaporates, and we are losing materiality. But the 3 of them are fun to experiment with.
Yeah, I find with the lab grade one that I'm going to be using, it looks a bit plasticier, a little bit more like the gelatin effect, and I find that it has a little bit more elasticity compared to the other 2, which is not better or worse. It's just good to know these things about what you're working with.
Would it be an appropriate moment to take a question from the public?
Sure.
Right, because I think it's just aligned with what you mentioned. A few questions. I'm piling up questions for the question period, but one is just related to what you're saying. Participant thought that versus agar versus glycerin or glycerol. So participant asked, I thought it was said that the agar is supple, glycerin rigid. Glycerol adds flexibility derived from agar. So if you could just explain a little bit about this kind of I would say difference between both, because participants are just maybe unsure about the subtleties of the difference between both. So what adds flexibility? What makes it rigid? If you could provide more details.
Yeah, it's mostly when we play with glycerin. When we pour more glycerin, we have more flexibility. Less glycerin, it becomes harder, and it's mostly about that. Now, gelatin also versus agar, gelatin is more hard than agar, but the same, we can play with this range by putting more or less glycerin. You want something to add?
We should maybe just repeat that glycerin and glycerol is the same thing. It's just a word for the same molecule, right?
Yeah, and if I can continue on that, I think the name gelatin and glycerin are kind of confusing, at least in my head. So they're 2 different things. The glycerol or glycerin is the plasticizer, is what allows the flexibility of the material, and the other 2 are really the base compounds we use to make the thing itself.
Yeah. Here you have the vegetable glycerin that we buy from Cobb Cocoa, but you can find it at the pharmacy too. And here we have the gelatin that we buy at bulk barn, made from animal like bone, porks, and that we got in the class. And this is the agar. So it's true that glycerin and glycerol is the same product, but they have 2 names. And glycerin and gelatin could be confusing, but it's 2 different things. Did we answer to the question?
And glycerol is a liquid.
Glycerol is the liquid like gelatin, yeah?
Yeah. And you use glycerin or glycerol in both recipes. And so it adds flexibility to both an agar recipe and a gelatin recipe. It's just that agar is inherently, it produces a more flexible material than gelatin. So what you, I don't know if I'm explaining this well, but with the agar with glycerin, with more glycerin, you're going to get a very flexible material. Mm-hmm. Basically, you add it to both, and it adds flexibility to both. But agar just happens to also be inherently more supple and more soft than glycerin, or than gelatin. Sorry.
I think it answers the participant's question really well. Thank you so much for this precision.
Thank you. So let's start cooking. So
yes.
What we notice is very important to.
I just want to ask and just be aligned on the ratios first. So we're gonna do 4 grams of agar
mm-hmm. That we already
on 100. Yeah, it's all prepared. So just so you guys know, but we'll post it in next week. But 4 grams of agar, 125 grams milliliters of water, and we're gonna use probably different consistencies of glycerin today. I'm gonna put half a teaspoon.
Okay.
And I wonder what size.
Well, on my side, I'm gonna use 4 grams of agar, and I'm gonna use 150 milliliters of water, because usually I use 120. But yesterday, I noticed that it was a bit just. So this is really like cooking. Like you have a recipe in a book or on internet, and you adjust. Like, the recipe is telling you this is how much ingredient you have to put, but you have the feeling that you want to do something else. And this is the same with bioplastic. But it's why it's very important to write, keep track of what you do, and then you can decide to change and adapt again. And I'm gonna use a teaspoon of glycerin on my side. What about you, Alex? What are you doing?
I'm doing a slightly different recipe as well, but it's all about the same, but I'm using 4.5 grams of agar, 120 mils of water, and I'm using 3.75 grams of glycerol. And yeah, we all kind of have different preferences as to whether we like to use teaspoons or tablespoons, but I like to weigh everything. It's kind of how I learned how to bake, and so I feel like I've transferred that knowledge over to have things as precise as possible. So I don't know if that is half a teaspoon or what, but it's 3.75 grams of glycerol.
Yeah. So what we like to do is to work everything from cold. So I put the heat on, but I know Miri is using a different technique, like she's mixing everything cold before. So first the water on my side, then a teaspoon of glycerin. I don't want to lose anything, so I put my finger in it. It's already cooking.
As you're cooking, if I may say, the correspondence between teaspoon and milliliters, in a teaspoon, there's 5 milliliters. So Alex is putting a little more than half a teaspoon.
Okay, so I put
5.
We're
and in terms of grams, the density of glycerol is about 1 gram per milliliter. So if you put 3.75 grams, you put about 3.75 milliliters.
Thank you.
Just technical information. Sorry.
No, I love it. No, I somehow never bothered to look that up because I just started doing it by weight, but it's useful for me and for everybody.
Thanks, Eve, for the...
Thanks for the chiming in.
The measurements, yeah.
Notice when I put a tablespoon of glycerin is 12 grams. Would you agree with that?
Well, are you sure it's not a how do you call the bigger spoon there?
The big spoon? Tablespoon? There.
While you're stirring your recipe, would that be a good moment to take a question from the public?
Of course.
Someone was wondering, like the person was interested in knowing more about the nature of sodium alginate versus to agar and gelatin.
Okay, so I have a question for Eve, but this is not to mix everything, and we're gonna address that later, because the sodium alginate, we use it mostly when we make biocomposite with eggshell and mussel shells, because they're made of calcium, carbonate, and we mix it with vinegar. So maybe.
But maybe we can go in the fine detail of the chemical reaction after when we speak about biocomposite. But just for the as a general comment, and it's interesting because it contrasts, what things actually are and what they produce, and like the difference also between arts and science method. I think it's a nice parallel. Sodium alginate, correct me if I'm wrong, Miri, Vanessa, and Alex, but it's used to solidify materials, to make things stiff, right?
But and I want to bring Eve to this conversation, because I think what is happening is the vinegar aspect, and the acidity of the vinegar is a key element when we mixed the eggshells, the sodium alginate, and the vinegar. What do you think, Eve?
Well, if I answer the first question, what is alginate? It's also, sugars are very diverse in nature. If you think about the sheet of paper that's made out of sugar, if you think about cellulose, wood, it's also made out of polymers of sugar. It's the same thing for alginate. It's also a polymer of sugar, similar to agar. The difference is that the composition of the sugar is a little bit different. It has, in chemistry, we call this carboxyl group. So it's like having a strand with handles. Like for every sugar, there's a handle. And it's called a carboxyl acidic group. And that property, the reason why it has handles, not the reason, but the consequence of having handles like this is that its reactivity could be different. And it is different, as you will see when Vanessa and Alex and Miri are presenting what they're doing with eggshells. And so these handles react with calcium. So what is solidifying the strands of alginate is the reaction between the calcium from the eggshells and the alginate. And again, we can come back to this reaction more specifically later on if you want, but basically it's the same type of product. Alginate is extracted from an algae, also not a red algae like agar. It's extracted from a brown algae. And so it plays a similar role also in the brown algae as agar plays in the red algae. It's vegetal. Also, it's not extracted from animals. And so it's a very interesting product to play with.
Mm-hmm. Thank you.
I just want to bring us back to the cooking for a second. Just notice that we're always mixing. See, this is really part of it's an important part of the recipe, to always keep the ingredients kind of moving, circulating, so that the agar doesn't sink. And we're trying to create a consistent texture. And probably, Eve, when you work in the lab, you have the magnetic circulating hot plate. So it serves to always keep the materials just even in the mixture.
Yeah, and we stir it until it brings to the boil. Like on the Material website, they talk about 95 degrees, but like personally, like I let it boil. When it's big quantity, I let it boil for 1 minute with bubbles. You're gonna see the bubbles soon. But when it's little quantity, because it's half of the ratio today, I don't leave it as long. But maybe, Eve, could you explain what is going on at the moment? The connection between the heat, the water, the glycerin, and the agar. Could we talk about polymerization like for real plastic?
Well, yeah, I mean, there's a difference between, I'm actually not sure exactly what's going on in your pot right now. The only thing that I can say is you had a lot of water, so you're dissolving everything. And so everything is floating in water. So you have the strands that if you dried your mixture, if you removed all of the water, your strands would then not connect chemically necessarily, but organize themselves in such a way, I was giving the analogy of Lego block, they would stick together and they would form a very hard structure. And upon removing the water, glycerol is soluble in water as well. So upon removing the water, the glycerol inserts itself between these strands. And so right now what you're doing is by heating, you're probably just taking apart the different strands of agar, especially to make sure that everything is well dissolved. And that would allow, when you're drying, when you're removing the water, that will allow the glycerol to insert itself between the different strands. This is how I understand it.
Okay.
Of course, we haven't studied it, so take this with a grain of salt. That's probably what's going on.
Thank you. And I just want to have a look at this bubble here, what is happening here. Like for me, this is the indication, like I call it polymerization without really knowing it, but I feel like the plasticity is happening at this point, you know, when I see the bubbles. And maybe to answer to Larissa's problematic with more molding, maybe you didn't let it cook enough. So it's, you know, this plasticity, this like you were talking about Lego blocks before, like they didn't have time to combine. And maybe it's why there is more mold, because at the beginning we used to have more molding, but recently we don't. So maybe because we increase the heat, maybe we let it cook a bit more. So this is something that, you know, Larissa and the students in Alice's class should experiment more with, like let it cook a bit longer.
Can I ask a very practical question to the collective? What size of pot make a difference? This is coming from a participant in critical materiality. Does it matter?
Like I can answer, and then I let Miri and Alex answer what they think too. Like for example, I was mentioning like 2 minutes ago that because I don't use too much quantity today, I don't let it cook as much. So you have to see like this bubbles aspect is quite important. And I don't think the size of the pot matters. It just like the boiling, the ebullition must take place. For me, is what is important. What do you think, ladies?
And oh, go ahead, Alex. I'm sorry. Yeah.
That's fine. No, I was just going to say, because we're making such a small recipe today, I probably wouldn't use a huge pot, because then there's going to be too much surface area, and then the liquid, the bioplastic is going to spread out too much, and I feel like the water will evaporate. Maybe this isn't the scientific way of explaining this, but I feel like the water would evaporate too quickly. I kind of use the size of the pot depending on the amount that I'm making. So I'm using the smallest pot that I have that I've dedicated to bioplastic making today.
And also we have a question from the public on YouTube from Frederick Carter, who's wondering if bioplastic is toxic, and if it's bad if animals eat bioplastic. Maybe Eve knows the answer, or Vanessa, or.
But I would let Liv answer. But my own feeling is that while we're using culinary ingredients found, you know, like mostly commonly found in the kitchen, for me is not toxic for animals. But I'm curious to see what Eve has to say about it.
Well, you're using glycerol. Glycerol is a natural molecule that holds together the fatty acids from your body. So the triglycerides, there are 3 strands of fatty acids, and they're held together with glycerol. So this is a natural compound that you eat every day from your food. And agar or alginate, they're sugars. There might not be as easily degraded in your body as other sugars, the more common sugars that we eat regularly, but certainly they're not toxic. You know, it's the same thing as if you would eat a piece from a sheet of paper. Basically, you would not really gain anything from it calorie-wise, but you would not get poisoned by it. So the answer is most likely no, unless there's something else. I know that Alex, Vanessa, and Miri are using dyes and are using natural products. We have to be careful about what we call natural products, because not all natural compounds that are out there in the environment are innocuous. You have poisonous mushrooms, for instance. You have, Vanessa was telling me about
resin, pine resin.
Noyau. What's the word in English for noyau?
Seed. Seeds.
Yeah, the seeds. Yes, the seeds of avocado that can contain a toxic molecule. So you just have to be careful about what you're adding to your bioplastics and making sure that those are not toxic. Of course, it's not always easy to know, but there's a lot of information out there on the web, and certainly you can check.
Yeah, and this question brings a very important conversation that we had many times with Eve. Like, it's not because it's natural that it's not toxic, like many things are toxic, but talking about the seeds, like apple seeds, pear seeds, peach seeds, they contain cyanure when ingested. But we had this conversation with Eve, like the connection between the saliva and the stomach make this poisonous aspect, not necessarily when it's in a plastic. But just because, like,
also maybe,
yeah.
Oh, sorry.
You know,
I was just going to say about glycerin, like maybe in a large quantity is not really recommended for animals. Like I know chocolate is really not good for dogs, for example. So
or milk, like that.
sugars and
Okay, so I'm done.
It's a really important question, because also to bring up the idea that we're attempting basically to replace commonly used plastics, or we're aiming to become sustainable, or to show different alternatives to the materials we use in our daily lives. But really, is it more sustainable? That's a really important question that we tend to raise, because everything, even our agar, like you've explained, the extraction of gelatin, all these processes require so much industry, shipping, extraction. So I think it's really important to become aware of these questions, because personally I came to this really naively and like, yeah, we're gonna change the world with bioplastic. But when I researched about agar, actually in Alice's class last year, I was shocked on how much extraction it takes and how much environmental impact it has. So
that's what we call life cycle analysis, and that is very important indeed. I can only agree with you, Miri, but one of the main differences between bioplastics and the regular plastics that derived from petroleum is the fact that they're biodegradable, and so they do not, or they will not accumulate as much as the current plastics are, creating those islands in the ocean and microplastic beads that you find everywhere, and filaments and so on. That's a major difference to me. So the extracting and preparing bioplastics might not be as sustainable as we are tempted to think, but certainly in terms of the impact on the environment, bioplastics will be much less impactful than the petroleum-derived plastics.
I'm done with my cooking, and I don't know if you noticed, but I stopped the heat, and for 1 or 2 minutes I keep stirring. And it's not that liquid, but it's a bit syrupous, like a syrup. And I'm gonna pour it now in these 2 yogurt tub. I don't know if the images.
Oh, it's so beautiful. You're pouring it. The contrast is so high that it looks like you're just pouring it into a beautiful abyss.
And magically, the shapes occur.
It's magically shaping.
Yeah.
Where do you pour it, Vanessa? It's really hard to see. It's in a jar, or
it's a yogurt lid.
Okay, now we see the contour of it, but it looked like
yeah, it was magic. It was
like a circle was magically forming on your countertop.
And just to show you that this is one we made yesterday, so I'll show you maybe on white. You see more the contrast. So it's already shrinked a lot from yesterday, you see, and but they don't stick, like after. Usually we wait the following day before to remove them from the mold, but with this Agar 900, after half an hour you can remove it, and then you can form your little shape like you could see on the platform. You can decide to put it on a little glass or cup and close it, to get little shape, or you can make a little plate. Like this one I made 2 days ago, this one. No, this one is this one. Sorry, so many. Yeah.
Oh, that's good.
So you see, it's 2 days old, and it's still soft. So it takes about a full week, I think, to get fully dry. But what is very important is every day you check on it and you take him. You know, you inverse the shape of the plates and you check the molding.
Yeah, that's important for sorry for repeating your name, Larissa, but no, always check, kind of clean your dishes, maybe even use alcohol or vinegar, but it's kind of it's a maintenance. It's like babies.
Yeah.
And the if I may ask or relay rather questions from participants, someone mentions like that the mold has kept coming back and that looks like it has penetrated the material. Then it seems that the mold can be removed. Is there a solution?
Oh, it was stuck to the mold?
The mold, well, the mold, the moisissure was...
Mold, this one. It cannot be removed. I never had this problem, honestly. So maybe if Larissa can express herself and saying, you know, reacting to what I said before, did you cook it for long enough? Did you wait until this ebullition point, Larissa?
Hi, Vanessa. Yeah, so I cooked it. I do remember having trouble, like I let it boil, but I do remember having a bit of trouble with like the consistency because I felt like the glycerin kind of became little bunches. But I mean, eventually I got it to be consistent. In terms of like the mold, well, I tried different ways. Yeah, I just brushed it away. Then I did vinegar. You know, I think I could have checked, you know, better. And I think the first time I did not use vinegar. So that could be one thing. But I've noticed that now the mold and some of them has penetrated, I think. So then it seems that it's not possible to, you know, remove the mold, right?
Okay, so yeah, if it's inside and if it's your first test, maybe I encourage you to try again. Which recipe did you use, like the gelatin, water, and glycerin?
Yeah, from your video, yeah.
And which dye did you use? Natural dyes or like food coloring?
Yeah, so because I've been experimenting with turmeric for other projects as well and masks, I used turmeric and I also used a dye that I had created a while ago from onion skins.
Okay.
I must say that the glycerin, personally, the scent of the glycerin or the odor was quite disturbing. Yeah. It kind of discouraged me to want to try it again with that. And
the glycerin or the gelatin?
Sorry, gelatin. Yeah, the gelatin.
Pretty intense.
The gelatin smells.
I really, relate.
So the turmeric helped actually.
It helps to mask it, yeah, for sure.
Yeah.
I used the avocado dye with the gelatin and I actually found it pleasant, the two together. So
yeah.
And I use the air extractor when I cook gelatin.
Because
I just want to say, I have a crucial moment, if I can just say. You see that my mixture, I didn't add any dye to it. And I'm gonna add a little syringe of sauerkraut juice that I had in the fridge. And there's a reason why I'm adding it now at the end and not cooking it. And I think Eve can explain why I'm doing it, because I don't want the color to fade. And that's why I'm just adding a little bit in the end to create this pinkish. I'll add a bit more.
Do you want me to explain now, Miri?
Yeah, if you can, it would be great.
Sure. So the color is given by compounds that absorb radiation from light, and the absorption of the radiation is dependent on not the composition, but the structure of the molecule. And when you heat it up, sometimes the structure changes, and because the structure changes, it does not have the same absorption characteristics, so it doesn't give off the same color. And so it's just a simple transformation of your molecule. It gets a little different. Sometimes it's very minor, but that minor change in your molecule that causes the color is enough to change the color, or just stop producing the color.
Yeah, like while you do that, Miri, this is I'm showing another test I did here. Like I did the same as you. When I poured the hot liquid in this mold, it was transparent, and then I added the color while it was still liquid, and I was stirring it with a little piece of wood, and you can have fun and play with different, make shapes, patterns, drawings while you play with the color still in the liquid.
A participant is asking how much dye you recommend using.
Ooh, it totally depends on the kind of dye you're using and the method that you want to incorporate it into your bioplastic. Like sometimes when we're using onion dye, we'll use only onion dye as like replace the water in the recipe with onion dye. I think when Vanessa's using food coloring, you'll use, what was it, 10 or 12 drops of that? Or was it
2 or 3 drops is very powerful. Like,
yeah.
And
2 or 3
drops, yeah.
Drops. What I'm going to use today is this natural amaranth dye that I made from an amaranth plant that I grew in my garden this summer. And for a recipe of this size, I'll probably use 15 drops of it because it's not quite as potent as the food coloring. It's really a matter of just getting accustomed to the coloring that you want to choose, I think. But to go back to Larissa's question about the molding a little bit as well, something I'm in the process of trying, which might help you. I don't know, I haven't had results from this yet, but sometimes when I'm making natural inks and I want to try to preserve it from molding for longer, I'll add a clove or some wintergreen oil. So that's also something that I'm in the process of exploring if there's a way that I can incorporate that into bioplastics yet. But I'll keep you posted.
And another question from participants that deals with heat. Does heat accelerate the hardening process of bioplastic?
Oh no, the heat, no. It has to be really dry. If you heat it again, like I was also trying all kind of things, and I put my bioplastic in my backyard during summer, and with the sun, it melts it again. So no, the heat doesn't help drying. It's really like room temperature.
And like, what about air? Does air accelerate the hardening process? Like using a fan or wind or?
I would say the dryness of the air, yes, but I don't know. I never tried, but it's a good idea to experiment with fan.
Yeah, the level of humidity, maybe, like the more humid a room is, I guess the longer the drying process is.
Yeah, I think, oh yeah.
No, go ahead, Miri. I didn't want to interrupt.
I just want to show this sheet of bioplastic. It's the most rigid I got so far, just a specimen, and I used gelatin. And it really is rigid because I think the way it's dried in the mold, I actually forgot about it. And so it had one side really not exposed to air. And I think in some kind of way that you probably can explain better, it helped the rigidity of the material.
Miri, can you show that sheet of bioplastic again? I think we haven't seen.
So it's super, it's like paper, but even more, it's like, sheet of. And so, and also what Vanessa mentioned with the sun, for me, the sun actually worked in hardening the material faster. But I guess it's the right ratio, so it's not melting it. It's not direct sun, maybe.
Yeah, it was too hot. Yeah.
So if I can explain the hardening process. So you have this mixture of agar and glycerol, and glycerol likes water. So glycerol retains water. And so the hardening process is just the diffusion of the water molecules out of your plastic, right? And so this takes time because diffusion, it's not just like drying water on the surface of wood, for instance, or your counter. So it has to diffuse through your bioplastic and out of your bioplastic. So if you blow air on top of your bioplastic, you're basically removing the water molecules that are at the surface, And so that increases the diffusion out of the plastic. Same thing if you heat. If you heat, you're going to increase the diffusion of the water molecules through the plastic, and then it's going to dry faster. But as Alex said, you have to make sure it's not too much heat.
Mm-hmm. Yeah.
I also noticed that, it depends how much I cook. So for example, today you noticed we really cooked really slow and on low temperature. And this allows us to then later really shape the material. It offers it some kind of structural consistency, rather than if I just cooked it a bit less and left more water. So like you said, it will take a while longer for it to remove the water molecules. So that will be something different. The material that we'll get from it will be kind of more like saran wrap rather than a sheet of thick plastic. So.
Yes, exactly. And if you cook it longer and you remove some water by evaporation, there is less risk of molding. So I think it helps. Yeah. This is an example I wanted to show you too. It's a plate made of onion dye, and I also added flakes of onion. And it's very, very hard. It's very, it's almost like resin, but it's just the same, like it was from gelatin, glycerin, onion dye, and onion bits. It's a bit shiny. I don't know if you see well the quality. And also this method, this way of working, really changed the way we approach waste, food waste, or any kind of thing we are about to put in the bin. Like this weekend, for example, I was having sushi, and then it was served in this amazing plate, and I thought, wow, because bioplastic takes so much, any shapes, you can really mold them. So I made a plate out of it. Yeah. You see, you could get any kind of mold you find will do. It's a bit shiny, but you get an idea of the kind of
pattern. Yeah, it really prints.
Yeah. And talking about molding, Miri, you have something exciting to share?
Sure. So this was really amazing for me to work with the two of you, because I never keep record of my recipes. I just make, and so adding this rigor to my methodology is really valuable, because then I can reproduce things. And I collaborated with a molding master to make a mold of a cup. So I have to find the right place. So maybe I'll show here.
I just have a little intervention before we take more questions, because this live cooking show and discussion will end in approximately 15 minutes. So we have 15 minutes of questions. However, I've been told that Yves Gélina has to leave simply because, we have other meetings, because we just jump in from Zooms to Zooms in this in the context of pandemic. So Yves, I'd like to thank you for your participation in this fantastic discussion. Thank you for your insights, for explaining those intricacies of plastics, materials, and chemical reactions to the participants and the public. And it will be a pleasure to discuss further with you at another moment.
Thank you, Alice. Thank you, Vanessa, Alex, and Miri. This was very, very interesting. And the only thing I want to say is if anybody, participants, have any questions that relate to chemistry, just my email address is available. You can ask anyone from the group, and you can contact me. Send me a question, and it'll be a pleasure to try to answer the question. So keep up the good work. It's really interesting. Thank you, and bye, everyone.
Bye, Yves. See you soon.
Thank you very much.
Bye.
Yeah. So something else we would like to address is also what, the name of our collective, Cyclical Matters, is because we are really interested in this circularity. Is it okay or is frozen?
Yeah, no, it's good.
So we find a way, after when we make our bioplastic, to avoid wasting, throwing things away. And so we decided, to stock our old bioplastic. So we found different techniques. For example, I made a kind of bricks
Yeah.
Or I make, like this kind of little hexagons, and then they are ready to be melted again in new shapes endlessly. And
I'd like, speaking of shapes, because we have many questions from the participants and the public, and we will need to conclude this discussion like in 10 minutes or so. So I'm wondering if you're willing to take a few questions from the public and participants. Because one question deals like with the size of things. And after that, another question deals with the scalability of this process within industries. So first question, based on your current experience, is there a maximum size for the articles that are produced? That's one question from the public.
We can answer that as to another project we are doing at the moment with Alice, and yeah.
Well, yeah, but like let's speak from the past. What is the biggest object that you produce?
Oh yeah, the big plates. I have my bigger plates.
Yeah, I think.
Yeah.
I mean, Miri, you've made a huge screen. I think that's the biggest thing. But
oh yeah, so like this is the bigger.
This big are fairly easy to achieve, like
about 5 millimeters. Or we will
8.5 by 11 thing. Paper sized.
Yeah, I think in every scaling up there are challenges because the chemistry obviously also changes and the relationship between the ingredients. So
yeah,
I don't think there is a limit. I mean, I would encourage you to explore and see how, for example, when I scale up with the gelatin, I use way less gelatin because I saw, wow, I need like 2 kilograms, but it didn't make sense in the amount of water, and I explored and it worked. So this is what's fun about it. They really have control of over making your material.
Yeah. And I'm like, this question comes from a participant in the class, and it was asked towards the beginning of your presentation, but I think it bridges really nicely with what you're discussing right now. And the participant asked, I would be interested to understand the broader context in the sense of the journey of bioplastic adoption in the industry sense. That means that we all know that like real plastic is like unhealthy, like it's dangerous for environment, it has impact on ecosystems. But how experimentation of this nature, like with bioplastic, is contributing directly or indirectly to science and engineering bioplastic work. That means that is bioplastic a potentially scalable process to replace or to contribute to like the plastic problematic all over the world? And it bridges with other participants' question that ask, can you wash your bioplastic, and how do you maintain this this material?
Yeah, but
it's great.
Yeah, Miri, you want to answer?
Sure. Yeah, washing it's challenging because it's soluble in water, and it's also about finding the right amount of water, not too much, but enough. And I found, yeah, that it does collect dust, for example. So it's interesting to see the relationship with dust, or different like daily things in relationship to this bioplastic. How much gelatin we use or glycerin we use does affect how dirty it gets. Yeah, sub-nature, exactly. And yeah, I have a blank, but I think
if I can jump also if you blank, or you didn't finish.
Yeah, I just want to say that for me personally, it's very important that it will be adaptable or scalable, and maybe this experimentation offers a kind of a more agency to ourselves as autonomous beings. If I can make my own cup, right? This offers me a really interesting possibilities, and I can remelt it if instead of washing it. So this kind of speculative project also offers different things, thinking about the way we interact with these daily objects, with a cup, with a dish. So
Do you know any projects that currently involve, say, engineers or material scientists and artists or designers to like work on research and development projects with bioplastic?
Yeah, we know plenty because being on Instagram, following the books. Probably Alice introduced to this book in our class. So there are many searchers, designers addressing biodegradability and bioplasticity. And for us, concerning us and our project, at first it was to use for the conference. So these dishes are made to use dry food like chips, peanuts, but you can wash it with a wet sponge. You can even wash it, put it under water and dry it, But if you leave it a long time in water, it's gonna dissolve after a while. And this why we're interested in this property too, because we can reshape it. But otherwise, in bioplasticity and the industry, you have the PLA, which is the polyacid bioplastic made from algae or starch from potatoes or rice. So, we are improving in this aspect, but like I would end in scientific, the way scientific and the article is always by saying more research is needed.
Mm-hmm. So may I ask, speaking of more research is needed, can I ask one last question from participants, and then I will let you conclude because we have to end this live streaming soon. So the participant asked that, are you aware or do you know any project that have been using fungi in connection or in collaboration with bioplastic to create like new forms of materials? So do you know if there's any kind of like, say, a mix between like fungi work, whether with mycelium or other things, and bioplastic? And are you aware of any artists, designers that work in the field?
Yeah, we know artists and designers working with mycelium. We know artists and designers working with bioplastic, but I don't know if I know a designer mixing the two. Is it the question?
I think the question is this, yes.
Mixing the two?
Yeah.
Not.
Yeah, that was the question.
Okay,
so not at the moment. Well, that's an avenue to explore.
Yeah,
because we know that, like,
maybe Miri and Alex knows.
Yeah.
Maybe this is a thing you were interested in, though, right?
Yeah, exactly. It's a beautiful question because I started my research my goal was to grow mycelium for sculpture. And then I just got stuck in the agar petri dish because I was fascinated by the material. So I think it's totally possible because the agar allows the mycelium to grow. So yeah, what if we create structures, we dip them in agar and then inoculate them? It's definitely part of my own research eventually. I'm just not getting there at the moment. Mm-hmm. But yeah, definitely agar as a life enabler. I think it's really interesting to think about it as well.
Yeah, it's a really nice way to put it. And finally, I think participants were extremely interested in your recipes, and they were wondering if you can post the brands that you are using, maybe on the Rencontre Interdisciplinaire website next to the bioplastic recipe, or just to, because they're really interested in knowing like what brands you use. Okay, and where to buy them, actually, where to source those materials. So if Cyclical Matter would like to share that info with the public, that would be extremely appreciated, I think, at least from the perspective of my chat right now. So yeah.
Why don't we can prepare an article that's specifically focused on what we use and where we source them. So
yeah, we're gonna post this article addressing what happened today, like as a summary with recipes, sources, natural dyes. Yeah. Mm-hmm. Also, we are curious to know if we saw Larissa's test, but like any of your students, did they encounter, success? Did they, did something work out of the recipe we posted?
It's a question for Larissa?
No, for the class.
Oh, for the class. Okay. the class in general.
Share something like a success, or I mean, we know there is no success and failure in research, but something they are happy to share with.
With with bioplastic, you mean?
Yeah.
I see Janice's is very beautiful.
Looks like Vanessa's too. It's so pretty.
Why I don't see? I cannot.
Okay, I will spotlight the video here.
Show me.
Show again.
I missed that.
Oh, can you show your bioplastic again?
No, it's really good.
That's perfect.
Yeah.
The one you use when it's hot, and then you add the color after.
Yes.
Yeah.
Two edges.
I try to draw different, but it sometimes I don't know. It really depends on the temperature of the liquid. When I add the color on it, then it will dissolve a little bit, so we get different pattern.
Okay, excellent. Very good.
Yeah. That's great. Thank you so much for sharing this experiment.
But I do have a problem, like when I try to mold it on something, but it's very difficult to remove it from my mold. So
Okay.
It really sticks to it. Yeah, really sticks to it. We sometimes just put a knife under just for the beginning, and then it's easier to remove.
Or like you take it off.
Also like every day. Yeah. Sorry, Alex.
Yeah. Say it again, Alex.
Move it around. Otherwise, if you leave a few days without moving it, can stick. The secret is to move it regularly.
Especially in the first couple days that you've done it, I would move it like every time you think of it, go and like lift it up a little bit and put it back. That helps, I think.
Great. Well, maybe in 2 or 3 minutes, if you want to offer some conclusion to your talk or wrap up. Personally, I would like to thank you as a collective for taking part in this fantastic discussion and sharing your recipe and taking part in this distributed process of making and sharing knowledge throughout the summer and the fall semester as well, in a time where we cannot be like physically together. Thank you so much. So it was a pleasure of both working with you across the development of this platform and today as a form of discussion. So I'll let you conclude as a group.
Yeah, but I mean, personally, and we exchange about that, the three of us, many times because we meet regularly on Zoom. We feel really enriched after this experience, like in terms of our methodology, in terms of all the new techniques that we learned through the last 6 months. So from my end, it was really enriching. I'll let you.
Yeah, it's been really stabilizing, actually, working with all of you through this process, especially in a time in the spring when everything kind of changed really suddenly and we weren't really grounded. Having this kind of, at the beginning when Zoom was this new thing, at least maybe it's been around for a while, but it was new to me, and we were meeting, and it was a really grounding process and completely transformed our method. And during this kind of crisis of material and crisis of space, we were able to find, grounding and creative energy together. It's really nice.
Yeah, and especially the way that plastic just infiltrated even more to our lives since the pandemic. I find that to research this materiality was really healthy for me, and I also mentioned that this methodology of rigor that I'm still challenged by it, but I'm really trying to incorporate more into my practice is really gold for me. So thank you.
Well, thanks to you three, and I will share the links to other tutorials you've published on Hexagram, the Rencontre Interdisciplinaire d'Hexagram. And I will also share it with the critical materiality students. And really, I encourage everyone to follow Cyclical Matter on Instagram. They always post their new discoveries, which are like more amazing every day. Yeah, that's true. I'm a big fan. I like all their posts. Yeah.
Thank you.
Thank you.
All right. So thank you so much, Miri, Alex, Vanessa. Thank you so much to all the students involved in the Critical Materiality seminar. Of course, there will be some follow-up between Cyclical Matter and students and the public. I think it's just the beginning of a great journey into bioplastic and sustainable materials.
Exactly. We are going to be happy to answer to more questions if you have. On the way, I'm very happy to see your result also.
Oh yeah, it's so lovely.
Thank you.
All right, have a great day. Thank you.
Everybody.
Bye, everyone. Thank
Merci.
you. Merci.